Welcome to exercise number 1, IPv4 addressing basics. So in this exercise we are going to answer 11 questions. Completely it is going to be the basic questions only. So let us see the first question. Define IP address. So here we have to write the definition for the IP address. Actually a lot of definitions you can find it. What is exactly an IP address means? An internet protocol address is a logical numeric address. So that can be assigned to every single computer or printer or switch or a router or any networking device as a part of TCP/IP based network. The IP address is the core component on which the networking architecture is built. No network exists without it. An IP address is a logical address that is used to uniquely identify every node in the network. So the definition is going on like that, but in a simple way, if you want to write, it is a logical address. So it is a logical address used to identify a host. Used to identify any host. So this is the definition. Okay, a simplified definition of IP address. The second question is command used to display the IP address of a computer. So what is a command? So the command is ipconfig. So ipconfig is a command which is used to display the IP address of a computer. The next one, the third question is two types of IP addresses in active use are. So what are the two different types of IP addresses we are using nowadays? Okay, so that is the IPv4 and IPv6. IPv4 and IPv6. So these are the two types of IP addresses in active now. IP addresses are used to identify dash in a network. Okay, the fourth question. So you can write, okay, there are so many terms available here. Used to identify a host or a PC or a device, okay, etc. So you can use to identify any of this in a network. Dash is responsible for global coordination of internet protocol addressing systems as well as the autonomous system numbers used for routing internet traffic. Actually here they are asking about an organization, so is going to be the responsible for the IP addresses. So the name of the organization is IANA. So this is Internet Assigned Numbers Authority. Question number 6. IPv4 was initially deployed on. So they are asking about the date. So it was deployed on 1st January 1983. Okay, so this is the date in which it was first deployed. Then the next question is IPv4 addresses are dash bit numbers often expressed as dash octets in dash notation. Okay, so this is a very important question, a basic thing. IPv4 addresses. So what is the notation we are using for IPv4 means? So we are using the decimal. So the decimal notation we are going to follow. Okay, that means the IP address will be using 0 to 9, the numbers only. Then often expressed as dash octets. So octets means a collection of 8 bits. Okay, it is going to be the octet. So how many octets available in a IPv4 address means we are going to have 4 octets. So there will be 4 octets available in the IPv4 address. Then the number of bits. IPv4 addresses are dash bit numbers. So total number of bits is 32. So 4 octets, 4 into 8. So this is going to be 32 bits. The length of IPv4 address is 32 bits. Then the 8th question is IPv6 addresses started deploying from. So from when IPv6 was started deploying means is in the mid of 2000s. So started from the mid of 2000s. So IPv6 was deployed. Then the ninth question is, IPv6 addresses are dash bit numbers and are conventionally expressed using dash form. So IPv6 addresses, we are going to write it, or we are going to express in the form of hexadecimal. So we are going to follow hexadecimal notation. So we are now in IPv4 addressing, subnetting and VLSN course. The next one we are going to soon we are going to publish a complete course for IPv6 also in the same channel. Now IPv6 addresses are dash bit numbers. So what is the length means? The length of IPv6 address is 128 bit numbers. So 128 is the answer here. Then question number 10. Both IPv4 and IPv6 addresses are generally assigned in a dash manner. So how we have to assign means in a hierarchical manner. Either 4 or 6, it should be expressed in a hierarchical manner. So both 4 and 6 addresses are generally assigned in a hierarchical manner. So the 11th question is, complete the following table. So a very big table is given to us. So once if you complete this table, you will come to know a lot of information about IPv4 addressing. Now if you see the table, classes. So IPv4 address is divided into 5 classes. There are 5 different classes available: class A, class B, class C, class D and class E. Now for every class we have to fill the columns given here. So for example, the first one is a range. So what is the range of every class? We have to write it. Then higher order bit in the first octet, the number of network bits, number of host bits, default subnet mask, CIDR value, total number of networks, total number of hosts per network and private IP address. Now, so we have to fill all these columns for the each and every class. Now let us go for the class range. So what is the range of each class? Now class A, the range is from 1 to 126. So this is the range of class A IP address. So if you take class B, so the range is from 128 to 191. So this is the range of class B IP address. For class C, the range is 192 to 223. So 2 to 3. So this is the range of class C. For class D IP address, it is from 224. So 224 to 239. For class E, it is 240 to 255. So this is the range of each class. Then moving on to the next one, higher order bit. So the higher order bit in the first octet for a class A IP address, it will be always set to 0. So 0 will be available. It will be always set to 0 here. For the class B IP address, the higher order bit in the first octet, it will be always set to 10. For a class C IP address, the higher order bit is 110. For class D IP address, it is 1110. Then for a class E IP address, the higher order bit in the first octet, it will be always set to 1111. So this is the higher order bit. Then we'll go to default subnet mask. So then we will come to the number of network bits and host bits. The default subnet mask for a class for a class A IP address, what is the default subnet mask? Means 255 0, 0, 0. So this is the default subnet mask for class A IP address. For class B, the default subnet mask is 255, 255, 0, 0. So this is the default subnet mask for class C, sorry, class B. For class C, the default subnet mask is 255, 255, so 255, 0. So for class C IP address, so the default subnet mask is 255, 255, 255, 0. Okay. Now we'll go to the CIDR value. So what is a CIDR value means? So the number of bits available in the network. So if you see this 255,000, so what does it mean? 8 bits, that means the first octet 8 bits, okay, it is for the network, and the remaining 3 octets, okay, that means 24 bits will be available for the host. So that is what a subnet mask is telling to us. Now, so the CIDR value for class A, it is /8. For class B, the CIDR value is 16, okay, because 16 bits available in the network port. Then for the class C IP address, the CIDR value is /24, okay. So this is the CIDR value. So 255, 255, 255. Now for class D and E, so this is not applicable, okay. So it is not applicable. So we cannot, we don't have a default subnet mask for class D and E. So not applicable. Then moving on to the number of network bits. So how many bits available? Okay, so we are going to fill this particular column. For a class A IP address, if you see, we already discussed the default subnet mask. So it says there are 8 bits available in the network port. So the number of bits available in the network is going to be 8 here. Then the remaining 24 bits, okay, so 8 plus 24, it is going to be 32. So the remaining 24 bits will be in the host bits. So these are host bits. Then if you are moving for the next class, class B, so the number of bits available in the network, that means network bits, it is going to be 16 bits, okay, for the network port, and 16 for the host. So 16 plus 16, it is going to be 32. Then moving on to the class C, okay, so 1, 2, 3, so 3 octets will be in the network. So this is 24. So 24 bits will be available in the network part. Then the remaining 8 bits will be in the host part. So same for class D and E, this is not applicable. So we cannot find this for class D and E. So up to this we have completed, okay. Up to CIDR value we finished. Then moving on to the next one, total number of networks. So how many networks available in a class A? Okay, class A means, so it is very clear. You can see from 1 to 126. So 126 different networks available here. So but we have to make it in a general way. There should be a formula for this. So what does that means? 2 to the power of, so the number of bits available in the network. So the number of bits available here, it is 8. So 2 to the power of 8, okay. Then 1 bit we have given for the higher order. So I am going to reduce that 1, okay. I am reducing that 1. So 2 to the power of 8 minus 1, okay. Then minus 2. So what is this minus 2? You will understand while doing subnetting, okay. You can just keep it as it is, minus 2. So this is going to be 2 to the power of 7 minus 2. So 2 to the power of 7, it is 128. So 128 minus 2, it is going to be 126. So 126. So if you find, just if you solve this, you will get 126. So 126 different networks available in a class A IP address. Then in a class A. Then moving on to class B. So we can apply the same formula here. 2 to the power of, okay. So number of networking bits. So if you see the number of network bits, it is 16, okay. Then I am going to reduce 2 bits, okay, because we have given 2 bits for the higher order, 1 0, okay. 2 bits is given here. Then minus 2. So this is equal to 2 to the power of 14, okay. 2 to the power of 14 minus 2. So the value will be, so if you solve, you will get, okay, 1 16,382 networks available here. So in class B, we are having 16,382 networks. So moving on to the class C, the same formula, 2 to the power of the number of networking bits, it is going to be 24. Okay, so 24 bits we have given. Now I am going to reduce 3, so minus 3. So because 3 bits we have given for the higher order here, so you can reduce that 3, then minus 2. So this is, if you simplify this, so the answer is going to be 2097150. So this many number of networks you can have in class C. Okay, so class C is providing 2091750 networks it is providing to us. Okay, now for class B and class E, so we cannot find this, it is not applicable here. Okay, moving on to the next one, total number of hosts per network. So in each network, okay, 126 networks available. In each networks, how many hosts you can have? Okay, so that is the thing. So the same thing, formula, the same formula I am going to take 2 to the power. So 2 to the power of number of network bits, sorry, host bits. So host bit it is 24. So 2 to the power of 24. Okay, so we are going to take 2 to the power of 24 and minus 2. I am giving minus 2. So what is this minus 2? Minus 2, why we are doing this? Okay, you will get answer while doing subnetting problems. Okay, now, so 2 to the power of 24 minus 2. So this is equal to, so 1677777,214. So that means you are having 126 different networks we are having in class A. In each network, okay, in each network you can have 16777,214 hosts you can have, okay, in each network. So that is the name. Now, so moving on to the next one. The next one is class B. For class B, I am taking the same formula. So 2 to the power of 16. 16 means because 16 bits available for the host. So 16, 2 to the power of 16 minus 2. So this is 65,534. So if you simplify that, okay, you will get this answer. So 65,534. So 16,382 networks class B address is providing to us. So in each network you can have 65,534 hosts you can connect. Okay, that is the meaning. Then, so moving on to the class C. So in class C already we discussed 2097150 different networks you can have. Okay, in class C is providing. In each network how many hosts we can have means 2 to the power of the number of bits available in the host. So we have 8 bits here. So 2 to the power of 8. Okay, so minus 2. So this is equal to, okay, 254. So 254 hosts you can have. Okay, 2 to the power of 8 equal to 256. 256 minus 2. Okay, it is going to be 254. So 254 hosts you can have in each network. So this is, okay, you can understand the power of IPv4. Okay, so the total number of networks in each classes and each network, okay, how many hosts, okay, we discussed this. There we are having something an interesting one which is called the private IP address. So each class A, class B, class C, so they are reserving some IP address as a private IP address. So what are they? If you take class A, for a class A the private IP address starts from 10.0.0.0. so from here to 10.255.254. I am not writing 255 because it is going to be a broadcast IP address that we can see later while discussing about the subnetting part. We will understand that. Okay. Now, so this is the range of private IP address in a class A. For class B, what is the private IP address means? The private IP address, it ranges from 172.16.0.0. So from here to 172.31.255.254. So this is the range of private IP address in class B. For class C, the private IP address is the range of private IP address 192.168.0.0. So from here to 192.168.255.254. 254. So this is the range of private IP address. So this is not applicable for class D and class E. So generally class D, okay, it is used for multicasting. Class E, it is for the research and development, R&D purpose only they are using this. So this is the end of the first exercise, exercise number 1. So continue with exercise number 2. Thank you. Keep watching.